We'll look at one more example of confidence interval for population proportion, and this time we're going to compute the number of successes ourselves. In the previous example from the textbook, in the textbook problem, the number of successes were given. So 500 subscribers, of which 135 said yes, they would upgrade. So the number of successes was given. So what if we have to calculate the number of successes ourselves? So here we will use the data that I have here on the side. Okay, we have data about automobiles models at random selected from 5 countries. And we have MPG, weight, drive ratio, horsepower, displacement, and number of cylinders given for this sample. Okay. Now, what we want is, suppose that we are interested in the proportion of 6-cylinder cars that have 6-cylinder engines. So manufactured in these 5 countries, and we want to develop a 98% confidence interval for the population proportion of vehicles with 6-cylinder engines. Okay, so again we define the context here. What is success? A car that has a 6-cylinder engine. Automobile, a model that has 6-cylinder engine. So pi is the proportion, population proportion, the true proportion of cars with 6-cylinder engines. Okay. Now we want the sample size. So we do a count. So if it is numeric value, we use count. If it is non-numeric, we have to use count A. So here this is cylinders. So we go like that. Then we have sample size is 38, of which how many have 6-cylinder engines? So here we can use what is called count if. There are 2 count if functions. So count if function allows only one condition for counting purposes. Count ifs, you can have multiple conditions. So here we need only count if the range. Okay, so the range is the cylinders. Okay, and what condition are we referring to? Here the condition can be specified in several different ways. Here, if you want the condition to be just a single number, like here, all we want to do is to count the cases where the number of cylinders is equal to 6. So we can simply enter a value 6. But suppose if we wanted 6 or more cylinders, then we have to say within quotation mark, say greater than or equal to 6, then that condition will get counted. Or if you want less than or equal to 4, then you can put within quotation mark less than or equal to 4. If it is a single value, then we can just type the single value like that, and it will count the number of cases where the number of cylinders is equal to 10. Okay. So now we define what that population proportion. Now we define what is sample P, the sample proportion. So proportion of subscribers in the sample. Okay, and that is equal to take the number of successes divided by this, and the rest of the example is exactly like what we have done before. So the only difference here is that we are counting the number of successes using count if function. Okay, so P is square root of P times 1 minus P divided by N. Confidence level is, we want what, 98%? So 1 minus 98% is 2%. So the cumulative probability now is 99%. So the tail area is 1%. So we can go to the table, Z table. We want 99%. So which will be like there. So if we take the 2.32 and 2.33, so the average is 2.325. So this will be the norm dot S dot I and V, and the cumulative probability is 1 minus alpha over 2. Then the margin of error is Z times the standard error of P, okay, which is of course the same thing here. Okay, and the limits are P, the sample proportion minus standard error, then sample proportion, margin of error, sample proportion plus margin of error. So same here, sample proportion minus margin of error, sample proportion plus margin of error, and they're all the same for both cases. And we interpret that we are 98% confident that the proportion of 6-cylinder engine cars is between these numbers. As you see, the margin of error is really high, and the interval becomes almost unusable. It becomes of not great use. So only these intervals are useful when the margin of error is small. So we'll talk about that in the next topic.